Today we are learning about exponents and how to write our prime factorization answers in exponential form. Exponents show repeated multiplication. Below is an example of an exponent. Every exponent has a base number attached to it. In this example, 8 is our base number, and the 2 is the exponent. We can rewrite this as 8 times 8. We will multiply the 8 twice because the exponent tells us how many times to multiply our base number. Exponents represent how many times a number, or the base, is multiplied by itself. Below are a few rules for exponents. The first rule is any number raised to the 0 power is always 1. For example, 3 raised to the 0 power equals 1. Any number raised to the first power is itself. For example, 7 raised to the first power equals 7. Exponents have 3 different forms: standard form, expanded form, and exponential form. Today we are going to be focusing on the expanded form and exponential forms. In this example, we see 5 as our base number and 3 as our exponent. This is written in exponential form. We know that the exponent tells us how many times to multiply out our base number. To the left of this, we see 5 times 5 times 5. 5 is multiplied out 3 times. This is called the expanded form. When looking at our exponential form, there are 3 different ways to say it. We could say 5 to the power of 3. We could also say 5 raised to the 3rd power. Or, since our exponent is a 3, we could say 5 cubed. In this example, we see 3 as our base number and 2 as our exponent, written in exponential form. The 2, our exponent, tells us how many times to multiply out our base number 3. So we're going to multiply 3 out 2 times. On the left, we see 3 times 3, multiplied out 2 times. This is our expanded form. There are 3 different ways to say this exponential form. We could say 3 to the power of 2, 3 raised to the 2nd power, or because this exponent is a 2, we could say 3 squared. Let's try a few examples together. This time we see the expanded form, 7 times 7 times 7. Since 7 is being multiplied, 7 would be my base number. My exponent would be how many times 7 was multiplied. 7 was multiplied 3 times, so my exponent is 3. So now we've written our number in exponential form. Now let's think of ways that we can say this exponential form. We could say 7, our base number, to the power of 3. We could also say 7 raised to the third power. Or, because this exponent is a 3, we could say 7 cubed. In this example, I see 2 is being multiplied in my expanded form. So 2 would be my base number, and 2 is multiplied out 2 times. So 2 would be my exponent. So now we've written our number in exponential form. Let's look at some ways we can say this number. We could say 2, our base number, to the power of 2. We could also say 2 raised to the second power. Or, because the exponent is a 2, we could say 2 squared. We can use exponents to simplify the prime factorization of a number. Remember that a prime number is a number that is greater than 1 and has exactly 2 factors, 1 and itself. Prime numbers are the building blocks of all numbers. Let's review and look at a few numbers together and determine if they are prime or composite. The first number we're going to look at is 27. Think to yourself, what are the factors that can be multiplied together to equal 27? Does 27 have more than 2 factors? If so, it is composite. If 27 only has 2 factors, 1 and 27, it is prime. Think for a minute, would 27 be prime or composite? "27 would be a composite number because it has more than 2 factors. Let's look at 5. 5 only has 2 factors. We can only multiply 1 and 5 together to equal 5. So we're going to circle 5 because it is a prime number. It has exactly 2 factors. We look at number 9. 9 has more than 2 factors. We can multiply 1 times 9 to equal 9. We can multiply 3 times 3 to equal 9. Since 9 has more than 2 factors, it is composite. When we look at 19, 19 would be a prime number. We can only multiply 1 times 19 to equal 19. Since 19 is a prime number, I'm going to circle it. Let's look at 51. Can you think of any factors other than 1 times 51 that when multiplied together equal 51? '51 has 2 additional factors. If we multiply 3 times 17, it equals 51. Since 51 has more than 2 factors, it is a composite number. Looking at 17, can you think of any factors that can be multiplied to equal 17 other than 1 times 17? There are no more factors that when multiplied together will equal 17. Since 17 only has 2 factors, it is prime. So we'll circle it. Last, we'll look at 57. We know we can multiply 1 times 57 to equal 57. Can you think of any other factors? When we multiply 3 times 19, it also equals 57. 57 has more than 2 factors, so it is a composite number. Now we're going to learn how to use prime factorization with exponents. Prime factorization means you are breaking down the number into the smallest factors possible. Remember, a factor is a number that gets multiplied to find the answer or product. When we multiply all the factors together, the product is our original number. Let's look at an example together. 45 is our composite number. When we break down 45, we can break it down into 5 times 9. 5 is a prime number, so we can circle it. 9 is a composite number, so again we have to break it down. We can break 9 down into 3 times 3. Both 3's are prime numbers, so we can circle them. Now we are only left with prime numbers. When we write out all of our prime numbers, we're going to write them out in order from least to greatest. 3 times 3 times 5. Notice how we have 2 3's. 3 is multiplied out 2 times. We just learned about exponents, so we can use 3 as the base. 3 is multiplied out 2 times, so 2 can be our exponent. And then we're going to keep the times 5, because 5 is only multiplied once. It would not have an exponent. So our prime factorization, written in exponential form, is 3 to the second power times 5. Let's find the prime factorization of a few more numbers. The first one has been started for us. So 24 was broken down into 2 times 12. The 2 is prime, so we can circle it. 12 was composite, so we needed to break it down again. We can break 12 down into 2 times 6. 2 is prime, so we can circle it. And 6 is composite, so we need to break it down one more time. 6 can be broken down into 2 times 3. Both the 2 and the 3 are prime numbers, so we can circle them. Now we are left with only prime numbers, and we can write them out in order from least to greatest. I see 3 2's, so we can write 2 times 2 times 2, and then 1 3 times 3. I see that 2 is multiplied out 3 times. 2 would be my base number. It's multiplied out 3 times. So 3 would be my exponent. It tells me how many times to multiply out my base number. And then we're going to keep the multiply by 3. So the prime factorization of 24 is written in expanded form and in exponential form. In exponential form, we would say 2 to the third power times 3. Next we have 21. 21 can be broken down into 3 times 7. Both the 3 and the 7 are prime numbers. So there are no more numbers to break down. Next, we'll write out our prime factorization in expanded form. 3 times 7 in order from least to greatest. Since there are no duplicate numbers, there would be no exponential form for this prime factorization. Next we have 27. 27 can be broken down into 3 times 9. The 3 is prime, so we can circle it. 9 is composite, so we need to break it down. 9 can be broken down into 3 times 3. Both 3's are prime, so we can circle them. Next, we can write out our prime factorization in expanded form. I see 3 times. So 3 times 3 times 3. I notice it's multiplied out 3 different times, so I'm going to take that number as my base number. And the number of times it's multiplied out is my exponent. So 3, it's written out 3 times, so my exponent is 3. So the prime factorization of 27 has been written out in expanded form and exponential form. In exponential form, we would say 3 cubed, or 3 to the third power. When finding the prime factorization of numbers, we've learned how to use the factor tree method. Next, I'm going to show you another method called the ladder method. We're going to solve for the prime factorization of 600 using both the factor tree method and the ladder method. We'll start with the factor tree method. So we'll put 600 at the top. 600 can be broken down into 2 times 300. The 2 is prime, so we can circle it. 300 is composite, so we need to break it down. 300 can be broken down into 2 times 150. The 2 is prime, so we can circle it. When we break down 150, we can multiply 2 times 75. The 2 is prime, so we'll circle it. 75 can be broken down into 5 times 15. We'll circle the 5, our prime number. And 15 can be broken down into 3 times 5. Both 3 and 5 are prime, so we will circle them. Now let's look at the ladder method. Every time we see this symbol, it means to divide. It's important to note that we can only put prime numbers on the outside of the ladder. We'll start by writing 600 inside the first ladder step at the top. We know we need to divide 600. We need to divide 600 by a prime number. Let's start with 2. 600 is an even number, so it can be divided by 2. The number we divide by will go on the outside of the ladder. When we divide 600 by 2, we get 300. We'll write that on the next ladder step. Next, we need to divide 300. Let's also divide 300 by 2. We'll write 2 on the outside of the ladder step. And when we divide 300 by 2, it equals 150. Next, we need to divide 150. Again, it's an even number, so we know we can divide by 2, and that is a prime number. So we'll write 2 outside the ladder step, and when 150 is divided by 2, it equals 75. We'll write that on the next ladder step down. 75 is not an even number, so it can't be divided by 2. But we can divide 75 by 5. We'll write 5 outside of the ladder step. When we divide 75 by 5, it equals 15. We can divide 15 by 3, write that on the outside. And when we divide 15 by 3, it equals 5. Now we have only prime numbers left. We can circle all of our prime numbers. Now it's time for us to write out our prime factorization in expanded form. Notice how we have the same prime numbers in both methods. I'm going to write out my expanded form in order from least to greatest. I see 3 2's, so we'll multiply those out. 2 times 2 times 2. Then I see a 3 times 3, and then 2 5's times 5 times 5. Now that I've written my expanded form, I'm going to look for any duplicate numbers and write out the prime factorization of 600 in exponential form. I see 3 2's, so 2 would be my base number, and it's multiplied out 3 times, so 3 is my exponent. Then we'll multiply it by our 3. And then I see 2 5's. So 5 would be our base number. It's multiplied out 2 times, so 2 would be our exponent. So we could say the prime factorization of 600 is 2 to the third power times 3 times 5 to the second power. Remember, when using the ladder method, you can only write prime numbers on the outside of the ladder. Let's try a few more ladder method examples together. In the first example, we have 32. 32 can be divided by 2, and when we divide it by 2, it equals 16. 16 can be divided by 2. 16 divided by 2 is 8. 8 can be divided by 2. We'll write 2 on the outside of the ladder. 8 divided by 2 is 4. We'll put our answer on the next ladder step. 4 can be broken down. We can divide by 2, and that equals 2. We have only prime numbers left, so we can circle them. And we can write our answer out in expanded and exponential form. So first we'll write the expanded form. I see 2 5 times. 2 times 2. Since 2 is multiplied out 5 different times, we could also write this as 2 is our base number. It's multiplied out 5 times, so 5 would be our exponent. 2 to the 5th power. Let's look at 132. 132 is even, so we know we can divide it by 2. When we divide it by 2, it equals 66. 66 is also an even number, so it can be divided by 2. When we divide by 2, it equals 33. 33 can be divided by 3, and when divided, it equals 11. We're left with only prime numbers, so we can circle them and write our answer in expanded form. We'll write in order from least to greatest. I see 2 2's, so 2 times 2 times 3 times 11. We can also write this prime factorization in exponential form. I see two 2's, so 2 would be my base number. It's multiplied out 2 times, so 2 is my exponent. And then I have 1 3 and 1 11. So the prime factorization of 132 is 2 to the second power times 3 times 11. Lastly, we'll look at 144. 144 is even, so we can divide by 2. When we divide by 2, it equals 72. 72 is even, so we can divide by 2, and we get 36. We can divide 36 by 2 as well, and we get 18. We can divide 18 by 2, and we get 9. And 9 can be divided by 3, and when we divide by 3, it equals 3. Now we are left with only prime numbers, so we can circle them. And we can write out our answer in expanded form. I see 2 4 times. And then 3 2 times. This answer can also be written in exponential form. I see 2 is duplicated, so 2 would be our base number. It's multiplied out 4 times, so 4 would be our exponent. And we can multiply it by 3. 3 is also duplicated. It's multiplied out 2 times, so our exponent would be 2. So the prime factorization of 144 is 2 to the 4th power times 3 to the 2nd power. Now we will work on some guided practice problems together, and then you will have some independent practice problems to work on your own.